Hello and welcome back to Physical Geology. I'm Robert Lopez, your instructor for this course. And today I want to look at this exercise on earthquakes and locating the epicenter of an earthquake. And eScience Labs has a pretty good setup where you use Google Earth, and we really just can't get away from this. We have to use this Google Earth Pro because we need to plot something on the globe, and this is the easiest way to do it. But they also have this seismograph location KMZ file, which may be a little bit difficult to use. And also they have this, because we generate circles or we triangulate to get the epicenter, we have this circle generator that they have, and that's a little kind of complicated to use as well. So if you're having trouble with that, I have another earthquake epicenter exercise that do instead of this one here. But if you have success with the eScience exercise here, by all means do this one. But then if you're having trouble, you can try this other one I'm going to give you in a moment. They do have some demos here, so I've actually put links in the lab for going to look at this demo for using this software as well as using the KML generator here. And for those of you who have trouble with the eScience lab exercise, I'll post this one and you can do instead of the one for eScience labs. Now for this one, it's the same idea. We're going to have 3 stations. Remember, you need 3 stations to locate one point. So we sort of triangulate to find that point. Our job here is to figure out when the P wave arrives and the S wave arrives and figure out the difference between them to get this interval, this time interval. Because remember, the time interval is going to tell us the distance, right? The longer the interval, the farther away. The shorter the interval, the closer to the epicenter. And the easy way to do this is if we look at, for example, Sitka, Alaska here. So what I usually do, I see that the P wave, which arrives first, is arriving here at about 807.4. I'm kind of estimating there, 807.4. So we put that over here. The S wave is arriving at 811.5. And if we do this math here, it'd be 11.5 minus the 7.4. And we get 4.1 minutes. So that would be the difference between the S and P. So that'd be our time interval there. Now for Charlotte, North Carolina, we see here that it looks like it arrives at 808.5 and the S wave arrives at 813.4. And so for Charlotte, if we do the math, it'd be 13.4 minus 8.5. And that's 4.9 minutes. Now for Honolulu, down here, this one, the P wave arrives at 809.4 and the S wave arrives at 815.3. And now when we do the math there, it would be 15.3 minus the 9.4. So that's 5.9 minutes. So now we have the times. We have 4.1, 4.9, and 5 minutes for the time interval. So now our job is to figure out, using this time travel curve, when these two were top of each other. In fact, we'll use this one here. I just kind of blew it up here. And so what we'll do, and I've already sort of drawn a line here. So we want to use, so what I've done here in the preview mode, I've gone to the editing software and I've drawn an arrow here and I've drawn a line. So this first line, we're gonna start it off down here at 0 on the y-axis. And we want to know what amounts to 4.1. So we'll stretch this out here to 4.1, which is right there. So that's a time interval of 4.1, which corresponds to our Sitka, Alaska time. And we want to figure out where that time fits between the S curve and the P curve. And so if we bring this over, now we can move it, keeping it parallel to the y-axis here, we see that it fits perfectly right here. So that means that the distance for Sitka, Alaska to the epicenter is 1,500 miles. 1,500 miles. So on our document over here, we'll put for Sitka, Alaska, it's going to be 1,500 miles. For Charlotte, North Carolina, we said it was 4.9. So we'll bring this back down to the 0 here, and we'll go up here to 4.9, which is right about there. And now we'll bring this across, and we'll see where 4.9 fits in here. And 4.9 fits right around there. So that's 2,100, 200, 300, 400, 500. Yeah. So we'll make it 2,100 miles for Charlotte. 2,100. Now for Honolulu, we said it was 5.9 minutes. So we'll bring this back down here. And we'll stretch this out to 5.9, which is just shy of 6 there. Then we'll bring it up and see where it corresponds to. And it looks like it's up here about 2650, not quite 2700. So right in here, 2650. So there's our distances. Now our job is to plot these coordinates on the globe. You can either do it on this globe here or we can do it on Google Earth. If you use this, you need a compass. But with Google Earth, we can actually draw circles and it'll give us the epicenter. So let's plot these latitudes. And the way to do it on Google Earth, we're just going to enter the 57 degrees north latitude and the 135 degrees west longitude for Sitka, Alaska. So let's do that over here. So what I do, we kind of look at the latitude longitude, we'll put 57 north, comma, and then 135 west, and then we'll search for it. There it is. It's going to take us up here to Alaska. So there's Sitka, Alaska right here. Actually, Sitka is right on the coast there, but that's the latitude longitude they're giving us right here. So now our job is to draw a circle of radius 1,500 miles for Sitka, Alaska. So to do that, so there's our pin right here. We're going to go to use this ruler tool right here. Click on the ruler tool, and then we're going to make sure the radius is going to be in miles. Put it in miles. So there it's in miles. And then we'll go back to our diagram. We'll click once right on the pin, and then you can see we start stretching out the circle. And if you look over here to the radius, you see it starts increasing. There's 977. We want 1,500. So we keep going. So we're at 1,1400, 1,500. There's 15. That's probably as close as I'm going to get it. 1,500.81. So we'll do a second click, and it should lock it in. Somewhere on this circle is our epicenter, right? Somewhere on that circle. And so what we'll want to do now is we want to save this, and we're going to call it Sitka, Alaska. Save. And that should go to your temporary places down here. So there it is, Sitka, Alaska. So we have it there. Now we'll do the next location, which is Charlotte, North Carolina. And so if we enter that latitude longitude, we go to 35 north, and then we'll have 81 west. If we search for 35 north, 81 west, it takes us over here to Charlotte, North Carolina. Well, there it is right there. So there's Charlotte, North Carolina. We want to make it big so we can see our other circle. Now what we want to do, draw a circle of radius 2100 for North Carolina. So we click on our ruler tool. We're still on miles. Go to our pin, click once, and then stretch this out until it gets to 2100. Second click, we'll lock it in, and we'll save that, and we'll call that Charlotte, NC for North Carolina. And we'll save it, and that should show up in our temporary places. All right, so now we have two circles, and now two circles define two independent points. So the epicenter is either going to be up here in the Arctic, up in northern Canada, or it's going to be somewhere over here in the western United States. So now for our third location, which is Honolulu, Hawaii, what we'll do, we'll put the latitude and longitude. So 21 north, 158 west. And we'll search for that, and you'll see a pin drops over here in Hawaii. And now for Hawaii, we said we were at 2650 miles. So let's zoom out here so we can see the other circles. And so for this one, we'll do our ruler tool again. Click on the pin once, and then you stretch out, and then now we're increasing the radius here. We want to go to 2650. So there's 24, 26, well, 2647 is as close as I'm getting there. So we'll stop there. And then we'll save that one, and we'll call that Honolulu, Hawaii. Save that. Now we have our three temporary places there. What you want to do is take a screenshot of this, because you want to submit this pic with your lab so I can see your circles and your plotting of the epicenter. And then note that for mine, we'll zoom in a little bit here. They don't quite intersect at one point, but they all come pretty close to right in here. So what you would do, you would pick a point like right in the middle as the best fit. So the epicenter is going to be somewhere within this triangle right here, because that's where the three circles come closest together. So what you would do here is maybe if I pick this point where the hand tool is, if you look down to the bottom right of the screen, you says it's about 38.97 degrees north, 118.5 degrees west. So that's the numbers you would plot. And that would be the location of the epicenter using this exercise. Now, for the exercise I'll post for you to do, if you cannot do the eScience Labs one, is this one on the Loma Prieta earthquake. And so in this case, we have three seismograph stations, so station A, B, and C. You'll do the same thing. You'll determine the arrival of the P wave. You'll determine the arrival of the S wave. Note that here I have the S wave first, so you'll record the S wave arrival, then the P wave, and you do the difference, just like I did in my other video. And then once you do that, then you want to use, to get the distances, note that here we're using kilometers, right? So when you go to Google Earth, make sure you switch over to kilometers. And so here we're using this time travel curve. So here we have the P wave and the S wave. So again, you would make your little line here and move it over to the different distances to get you the distance in kilometers, right? And then here are the latitude and longitude. So you'll plot that in Google Earth. And then once you triangulate, you'll figure out to the nearest spot what the latitude and the longitude is. And then make sure you include a screenshot of your Google Earth plots. Well, that's it for now.